To perform our thin layer chromatography experiment, we will first put on gloves. With gloved hands, pick up your TLC plate, handling only the edges. Notice that the TLC plate has a shiny side and a matte side. The shiny side is plastic, the matte side is the silica coating. The silica coating serves as the stationary phase in this experiment. Using a ruler, measure 1.5 centimeters from the bottom of the plate and mark it lightly with a pencil. This will be the location of the origin, where you will apply your spinach extract. Measure 1 centimeter from the other short side of the plate and mark it with a pencil. We will use this mark later to determine when to stop our TLC run. Dip a microcapillary tube into the microfuge tube containing spinach extract. Place your finger on top of the capillary tube and touch the end of the capillary tube to the 1.5 centimeter mark on the silica plate. Release your finger from the capillary tube. Spinach extract will be deposited onto the silica. Move the capillary tube across the TLC plate to create a uniform line of spinach extract. Leave some space on either side of the spinach extract line. Let the extract air dry for a few seconds. Then you can apply another layer of spinach extract. Let the extract air dry between each spinach extract layer. Once you have applied 2 to 3 layers and your plate is dried for 60 seconds, you can begin your TLC run. Locate your chromatography chamber in the fume hood. The chamber is filled with a solvent containing petroleum ether and acetone. In this experiment, the solvent is your mobile phase. Check that the solvent level in your chamber is below the line of spinach extract on your TLC plate. Open the lid of the chamber and insert the TLC plate with the spinach extract end of the plate going in first. Replace the lid. You will start to see the solvent moving up the TLC plate. Once the solvent front has reached the 1 centimeter mark at the top of the plate, you can stop your run. With gloved hands, remove the TLC plate from the chamber and replace the lid. Let the plate sit in the fume hood for 1 minute while the remaining solvent evaporates. Identify the visible pigments on the TLC plate and take the measurements needed to calculate RF. You will measure the distance from the origin to the solvent front and the distance from the origin to each pigment band of interest. Now you will extract the pigments of interest. We will extract carotene, chlorophyll A, and chlorophyll B. You may also extract other pigments. First, label your centrifuge tubes with the names of each pigment. Then, use a metal spatula to scrape each pigment onto a piece of wax paper. Transfer the scrapings into the corresponding centrifuge tubes. Add 2 milliliters of ethanol to each centrifuge tube and give them a mix. Balance your centrifuge tubes so that they are within 1/10 of a gram of each other. Arrange the centrifuge tubes in the centrifuge so that it's balanced. Centrifuge for 3 minutes. After centrifugation, you will be left with a pellet of silica and the supernatant containing ethanol and the dissolved pigments of interest. First, we will prepare a blank cuvette. Take a clean cuvette and add 1 milliliter of ethanol to it. Obtain as many cuvettes as you have pigment samples. Label a cuvette for each extracted pigment. Do not block the optical path with your label. Using a micropipette, carefully transfer about 1 milliliter of supernatant from each centrifuge tube into the corresponding cuvette. Be careful not to transfer any silica into your cuvette. Use a new tip for each sample. Now we will measure the absorbance spectra of our pigments. First, we need to set up and calibrate our SpectroVis Plus spectrometer. Plug the USB cord from the spectrometer into a laptop. Open the program Logger Pro. The light in the spectrometer should turn on. Click the wavelength button at the top of the screen. Under Collection Mode, choose Absorbance versus Wavelength, then select OK. From the Experiment menu, choose Calibrate Spectrometer. Allow the spectrometer lamp to warm up for 90 seconds. Insert the blank into the spectrometer. Click Finish Calibration and then OK. Insert your first sample cuvette into the spectrometer. Click the Collect button at the top of the screen. The absorbance spectrum will appear right away. Note the color of the line for this pigment spectrum. Click the Stop button. Insert the next sample cuvette into the spectrometer. Click the Collect button. In the dialog box that appears, click Store Latest Run. This will overlay the current absorbance spectrum on top of the previous spectrum on your graph. Note the color of the line for this pigment's absorbance spectrum. Click the Stop button. Repeat this process for all remaining pigments. Be sure to click the Stop button for your final pigment. Now click the Auto Scale button at the top of the screen to rescale the axes. This will make the peaks more visible. Take a screenshot of your generated graph to analyze in your post lab.